My slide is visible. মানে দেখা যাচ্ছে slide.
হ্যাঁ স্যার।
So today we'll discuss about some symmetry, modern symmetry key cipher. Already we have discussed lots of cipher techniques and the key, keyless, then scissor cipher, and some different type of cipher techniques have been how to develop. Now today we'll discuss about the modern symmetry key cipher. Symmetry key means what? What is the symmetry key? Symmetry key means a same key, which is a shared secret key. And key is symmetrical means key is present on the sender and receiver side. Means the same key has been used for encryption and decryption. So symmetric key modern block cipher encrypts an n-bit block of plain text. Suppose you have taken a page and there are say 100 lines and each is divided into 10 uh, lines. Means one line has a say 10 or 50 letters. So then we just divide this into a equal size of block, that is called n-bit block, and this is considered as a plain text, and or decrypt an n-bit block of ciphers. Means always you have to consider the text as a block. So means number of bits in a particular block. And the encryption or decryption algorithm also use a k-bit key. Means a key which considered as a k bit. K means it may be 128 bits or it may be 256 bits or say more than 100 bits like this. So this is the number of bit. So why we are taken as a bit all the cases, because computer as a digital devices and they consider only the 1001 bits means binary number. That's why all the work has been considered in a bit level. Means if you consider any text, image, audio, video, finally it should convert into the bit and then it goes to the transmission, means convert into the signal, and goes the signal is a carriers or without carriers, means wireless or wire. So obviously we have considered the bit level of the plain text. So the text, any multimedia documents, text, image, audio, video has been considered or converted into bit. Then we take the block of bits. Okay, n bit has been taken and k bit key has been considered. Now today's discussions will be uh, covered by this section. This is substitution or transposition cycle, block or permutation group, uh, and then modern block cipher, product cipher, and two cases of product cipher and attack on block cipher. So some of the consider ciphers and different type of techniques where the modern block cipher is used. And nowadays people are using what type of ciphers and how that security it depends. Means what the enhancement of the security they can achieve. Okay. So first one thing, the modern block cipher is like this. Why it is called a block cipher? Because we have taken the n-bit block. So first, using encryption, we have taken n-bit plain text. N-bit. It may be any bit 128 bit, 256 bit, any bit of n-bit plain text, and then apply the encryption scheme. Encryption using k-bit key. So n-bit plain text and k-bit key, and observe that the k-bit keys are used both the encryption and decryption. That's why it is called a symmetry key. The same key has been used on the both ends. One is called the encryption and this is called the decryption. And then after encryption, using this k-bit key, we got n-bit ciphertext. So n-bit plain text, it was converted into n-bit ciphertext. No extra bit has been used or not has been inserted. Not any bit has been deleted, same bit length has been there. Now this n-bit ciphertext have to send to the receiver end. Receiver end will receive the n-bit ciphertext. Then decryption algorithm has been used using same key. Then the n-bit plaintext has been recovered. So this encryption and decryption algorithm is known to all. Means this has been published in different journals, papers, or it is available publicly. But you cannot get this K-bit key because this is secure. So without using this K-bit key, you cannot decrypt the message. These are the security. The security depends on the key, not the technique. The technique is known to all, or any genius can develop a better technique than you, but it is not possible to guess the K bit key because you consider the K bit nothing but the K is 128 bit consider. What will happen? If you take the key is 2 bit, then what will happen? There are two possibilities either 00 four possibilities 00, 01, 10, 11 because you have taken 2 bit key. If you taken 3 bit key, then what are the possibilities? 000, 001, so 8 possibilities. That is 2 to the power of 3. K is 3, then it is 2 to the power of 3. These are the possibilities. Now if you consider K is a 128 bit, what will happen? 2 to the power of 128 possibilities are there. You consider only 2 to the power 10 means what? 1024, 1024. 2 to the power 10 means 1024. Now what you consider 2 to the power of 128 means how many keys are there? So yeah, millions or trillions of keys are there. So from these keys, you can consider only one key to encrypt and decrypt the message. If some hackers hack your in-bit ciphertext but unable to get the k-bit key, then then these hackers should try trial and error method and using this key space. So there are trillions of keys are there. So from this key, it is not possible to decrypt the message because it takes more than 10, 20, 30 years because every key you choose a key and use the algorithm, then again choose a key. So the key space is more higher. So from this key, you cannot choose. It is not possible. That's why you can say the encryption is quite tough to decrypt without key. So this is the modern block cipher. Now come to the different techniques. Okay. So the modern block cipher can be designed to act as a substitution cipher or a transposition cipher. Already we have discussed what is substitution cipher and what is the transposition cipher. So now come to this one. This is the transposition cipher, the block cipher. Suppose you have the key 3 bit. Then what is the thing? You have a 3 bit key 1, 2, 3. Now a 3 object permutations only you can use means 3 bit. There is a 1, 2, 3. Or if you just change their positions, then it may be 1, 2, 3 or 1, 3, 2, 2, 1, 3 or 2, 3, 1 and 3, 1, 2 or 3. So these are the 6 possibilities for these three keys. 3 bit keys, there are 6 possibilities. Now the position has been changed. This is for the permutation. So only 6 elements you can get. So these are the 6 elements. 1, 2, 3, 4, 5, 6. So these 6 elements can be there. Means from this key, any key can be used to encrypt or decrypt. So you can choose very easily or trial method. You can use all these key, then obviously you can decrypt. But if you consider in this way, the substitution block cipher as a permutation model. Suppose you have a 3 bit key. Now you use the 3 into 8 decoder. Then what will happen? There are 3 bit. Now it can be considered as a from every bit there is a decoder, means 8 possibilities are there. So an object of 8 permutations, that is what is this? There is a 16 keys. That is you use the another key on the outside. It is called the 16 key. So for the 16 keys, okay, 16 bits. Now you have the 8 inputs bits 1, 2, 3, 4, 5, 6, 7, 8. So from this 8 input, you can consider these 8 permutations, 8 object permutations. There are 8 input lines. So from these input lines, if you use the permutation, then obviously there is a 8 factorials possibilities of permutations. So there is 8 factorials you can get on the output line, and then for every there are 8 factorials means 40,320 elements of keys are there. So from this key you can choose any one, and then you just decode encode the data from 8 to 3 and get the values. So what will happen here? Here the block cipher will just substitute the 8 bit in a different way, in such a way that number of elements, percentage elements are increased. That is 8 factorial. So from the 8 factorial, if you cannot choose the right one, then you cannot retrieve the message. So if we increase the key bit, the bit length, then obviously the system will secure. Okay, this is a substitution. Now come to the different component of the modern block cipher. Already you have just heard about that. The modern block cipher is used the substitution cipher, means it can be changed their positions, yeah, or permutation. Now you can use the different types of component by which you can use the more secure scheme. First one is called the P box, that is called the permutation box. What is this P box? A P box parallel the traditional transposition cipher for characters, and it transposes the bits. So it is the parallel traditional transposition cipher, means just simply the transposition means you can change their place. So this is P box also change their place. So you can use the P box, then obviously nothing else the permutation box. So how it can be used? So there are many, basically three types of P box. This is called the straight P box. Why it is straight? Because if there is an input, the number of input lines and number of output lines are same. Suppose there is input lines 1, 2, 3, 4, 5. Obviously, in the output line there is also 1, 2, 3, 4, 5. This input and output lines are same, but their position has been changed. So the position of 1 has been shifted to position of 4, position of 2 has been shifted to position of 1. So in this way, we just permute these 5 data places in a different way. This is the straight. Why it is straight? Because number of input and number of output are same. So if you take the 5 bits in the input level, then obviously you get the 5 bit in the output level, but the position is changed. But you can use a different another type of box which is called the compression box. What is compression? You take the 5 place in input line, but in the output line you can get only 3, because these two, any two can be eliminated. So if you take the 10101, then only you can get the 11, so 1, but no 0 there. So this permutation initially you can use a 5-bit key, but finally 3-bit key has been used for encryption or decryption. So it is not possible for the hackers. What was the 5 bits and which bits have been eliminated, which one or which zero has been eliminated, which part. So it may be there is no way to check that which 3 bits have been taken. It is 1, 3 or 5 or 1, 2, 3 or 1, 3, 4 or 1, 4, 5. So it is quite tough to reduce this one. This is called the compression bit. Another is called the expansion bit. Expansion means suppose we have used a 3 bit 1, 2, 3, but in the output level it becomes 5 bits. That means some bit has been replicated, means bit some bit has been doubles, means 2 and 3 is taken from the bit 3, and again 1 and 4 has been taken from the 1. So this is what 5 bit has been used when you give the 3 bit as the input. So expansion means data. So this is the P box, means permutation box. It is 3 types: straight P box, compression P box, and expansion P box. Okay. So compression means data has been reduced, and expansion means data bit has been expanded, the has been increased. So suppose you have taken a 3 cross 3 P box. Now different way you can use this 3 cross 3 box. So this is a straight, all are straight, but the places have been changed. See 1, 2, 3. Now this has been 1 has been placed to the second place, 1 has been placed to the third place, or 2 has been placed in the third place, or 2 has been placed, the 3 has been placed in the different way, and has been placed in the third place. So in this way, there is a permutation by which there are 6 possible mapping you can use for a 3 plus 3 box. Okay, so different type of mapping you can use. So for 3 input, we can use the 6 possibilities. But if you use the 64 bits, what is this? 1, 2, 3, yeah, this is a 64 bit. Suppose in the input level, you have used a 64 bit, and this is the P box. What is the meaning of this P box? On the 64 bit, whatever in the place of 58, that comes to the first. Whatever bit in the 50, that comes to the second. So this is first, second, third, fourth, fifth, sixth, seven, eight, nine, 10, in this way. So these are the number on the input level, whatever they are, that come with the first, then second, then third. So in this way, suppose we provide you this block, this box, state P box. What is the meaning of that? There are 64 bits is there from 1 to 63, and or from 0 to 63. It may be from, there is no 0, so from 1 to 64. So this is the 64 bits are there, and from this 64 bit you can use this box. Means what? These are the key. Means on the 58 plates there is, say something considered the line of the 1 to 64. So on the 58 place, whatever there, that comes to the first place. Then 50 place, whatever there, comes to the second place. So in this way we can use the encryption decryption using this straight keyboards. So if one can guess how, or any possibility, you can guess there. So it takes the 64 factorial of 64. So that possibility is there, and from these possibilities you cannot get the P. This is the main thing. This is called the permutation table for the P box. Now this is a compression P box. Suppose in a compression P box, you have taken a 32 in an input level, but in the output level it is 24. So some bit has been removed. So suppose 1, 2, 3 is there, 4, 5, 6 is there, but 7 is not there, 8 is not there, 9 is not there. So that has been removed. So the compression P box, by observing this block, you can say easily that it is compression, or it is expansion, or it is straight. So this is compression. Why? Because some bits are not there, and that's the places of bits. And 7, 8, 9, 10 is there, 10, 11, 12 is there, 13, 14 there, but 15, 16 not there, 17, 18, 19, 20 is there, 21, 22 there, 23 is not there. So some portion of the bit has been removed. This is called the basically compression P box. Okay, so these are the compression P box, and another is called the expansion P box. Suppose you have taken as a 12 bit in the input level, and in the output level 16 bits. Then 12 to 16. So 4 extra bits have been added. So what data there will be? Say here she say 01, 01 or 2 bits are there. That's why we can say the one place will come to the first, again also come to the first, second, third, fourth, fifth, sixth place. So in this way, this is expansion. Expansion means in the input level we have used 12 bits, but on the output level it has used 16 bits. So from 12 to 16 the key has been changed. So this is called the expansion because number of bits has been increased. So pbox invertibilities are there, A straight box is invertible. Invertible means you can get the reverse one, means you can get the original one. Suppose you have taken 101010 like this, and it has converted to the straight box. Then obviously when you study to find it, try to reverse, then you can get the original one. That is called the invertibility. So the straight box is invertible, but compression and expansion box are not invertible. So this inversion can be get in this way. Suppose this is the original table. Now we can use add these indexes. These are the original table 6, 3, 4, 5, 1, 2, 1. 6, 3, 4, 5, 2, 1. We add this 1, 2, 3, 4, 5. Then using this 1, 2, 3, 4, 5, we can sort the data, and then sorting data has been sorted, and sort after sorting we can exchange the data, means 1, 2, 3, 4, 5, and that come to the outside. Then outside is the inverted table. So this is the technique by which we can get the inversion. How we can get the inversion? I think that in a simple way we can get the inversion by this technique. Okay. Now come to the compression and expansion pivot. These are not invertible. Only the straight pivots are invertible, but compression and extension pivots are not invertible. Why? See the example. Suppose we have taken 1, 2, 3, but output level on the compression we get only 1, 2. So if we supply 1, 2 to you, then can you get the 1, 2, 3? No, because 2 is lost. So what will be the values of 2? You cannot say. It may be 0 or it may be 1, but it's not possible to say, or because the output of 2 cannot be assigned a definite value. That's why that is not possible. So this is not invertible. Again for expansion also, uh, suppose we have taken 1, 2, but here is a 1 is mapped to 1 and 2. Then if we invert this one, suppose one of these two, 1 or 2, suppose this is 1, this is 0. If it is 1 and if this is 0, then what is the value of 1? We cannot select, which is definite value. It will be 1 or it will be 0. It is not possible. So that's why this is not again the inverted. Now come to the another tools, that is called the S box. First one was P box, now come to the S box. So these are the tools. We are just discussing about the technique or tools by which we can use this technical tool for the for encryption technique in later. So AES, DES technique are there. Now there we have used. But these are the tools. One, the first one is P box. Already you know the P box. Now come to the S box. So what is S box? S box is a substitution box, and that can be thought of as a miniature substitution cipher. S means substitute, P means permutation. So already we have discussed the permutation. Now come to the substitution. Substitution means we can give a new one in place of old one. So for the substitution, suppose these are the formula x, y, and j, x1, x2, x3, and we take the x1 and get the y1, and from x1 we get the y2. So the y1 or y2 is the two output values, comes from the three output x1, x2, x3. So for these cases, you can use simply our matrix multiplication, and using this, consider 1, 1, 1. So x1, x2, x3, and there x1, come to the y1, and there is only one, so it multiplies the x1 and get the y. So these are the substitute. Means substitute means we can replace one value in case of another value, and thus S box may or may not be invertible. How? Suppose you have taken this one. In the input level, we have taken 3 bit. One is called the 00, 01, 10, 11. This is the 2 bit. And on the right hand side, we have taken the 3 bit. Another bit 1 0. So for the input say from 0, 1 0, we have taken 1 1 1. So for this 1 1 1, it's come from the 0 1 0. But when we take here this 3 bit, 111, then it is same as the 010. That means this S box is when you use for the encryption, the table is used for the decryption. See to check the data. If you use 010, means this row and this column, so this cell has been selected 111, and when you decrypt this one 111, then it comes the 010. So uh, and another one is see for the 001, 0 001, the output is this one 001, output is 101, output is 101. Come to the description 101, it is again 001. So this table has been used for encryption and decryption in the, so these two are the inverse to each other. If you use this one for encryption, then this can be used for the decryption. Okay, come to the another point or another tool that is called the XOR. You know very well about the XOR technique. So the XOR is an important component in the most block ciphers is the exclusive OR operation. That is XOR, so X and Y. If you use the K is a key, then you can XOR this key with the X. So X XOR key get Y. And again on the receiver side, if we again XOR this Y with the same key, then obviously we can get the result. Means the XOR operation when you use twice, then it's nullify and get the original result. So twice XOR with the same key, it can retrieve the original result. That's why XOR is important. But without getting the key, you cannot decrypt the message from Y to X. Without key A, you cannot get the data XOR. So XOR is the one way, and using this, you can get the data. So this is a technique of XOR, and XOR is closure from assertivity, commutativity, extension, identity, inverse. So this is why XOR is very important in the field of data encryption. Now come to the another is called the circular shift. What is circular shift? Simple, you know the shifting. Suppose we have used the data stream B0, B1, B2, B3, B4, B5, B6, B7, and we perform the shift operation, shift left on 3 bit. So the data has been shifted from left, means these 3 bits will shift and come to the front. So these B5, B7, 6 and B7 will come to the front. So this way the B4 will come here, then B3, B2, B1, B0, then B7 will enter here. So B7, B6 and B5. So after shifting, this data has been used. So my basically the operation on this area is that called the shifting only, yeah? Bit shift. You can use from left shift or the right shift. That is same on the left shift, only the direction has been changed. Another is called the swapping. These are the tools I am discussing, the tools which will be used for the encryption and decryption of message. The swapping is called the swap operation is a special case of the circular shift. Suppose there are 8 bits. Now you divide these 8 bits into two parts. These are the 4 bits, this is the 4 bits. Now you exchange these two parts. These are the left hand side part to come to the front, on this is the corner left hand side will come to the right. So this exchange is called the swapping. So you can do this swapping, and decryption, it is just reverse of the swapping. So you know the swap technique. Split and combine. Sometimes you can use the splitting operation. Suppose you have used 4 bits, now you split these 4 bits, 8 bits, 4 and 4. This is called splitting, and then you can add these two parts and combine the data, get the original. So this splitting can be used splitting and combine can be used in different uh, part when a technique has been developed. And another is called the product cipher. Yes, this is important. Shannon introduced the concept of a product cipher. A product cipher is a complex cipher combining substitution, permutation, and other components discussed in the previous section. This combination of these techniques produce a new cipher, which is called the product cipher. What is product cipher? The product cipher is a combination of different substitution, permutation, other techniques. So for that case, there is two important definition. What is called a diffusion. What is called a diffusion? The idea of diffusion is to hide the relationship between the ciphertext and the plaintext. Suppose I give you the ciphertext, then you always find what will be the plaintext. What will be the plaintext? So if there is some relation between the ciphertext and plaintext, then obviously we can easily find out the plaintext. If we try to hide this relationship, means we can there is no relation. You cannot find any relation on this ciphertext and plaintext. That means the technique have a good diffusion. Means the diffusion is a very good in particular technique. So the diffusion hides the relationship between the ciphertext and plaintext. Okay, so the hackers try to say suppose any terrorist sends a message to another terrorist and using the encryption technique, then obviously the security persons if they receive the message, then obviously without any key and others, he try to find the relationship between this ciphertext and the plaintext. And if you find any relationship between the ciphertext and plaintext, then obviously you can easily decrypt the message. But the techniques or the terrorists, they try to uh, hide the relationship. If you think that there is no relationship, technically they cannot find. If this relationship hides, uh, then you can call that this technique is a very good technique, and the diffusion uh, is a parameter by which you can say that these are the relationship height on the ciphertext and plaintext. Another is called confusion. These two techniques, two important terms you have to keep in mind. That confusion. Confusion means the idea of confusion is to hide the relationship between the ciphertext and key. The previous one is the ciphertext and plaintext. This is called diffusion. And confusion is the ciphertext and key. So if key is available, then it obviously you can decrypt the message. But if say the key is not available, then you have to guess the key. Then if there is some relation between the key and ciphertext, then obviously hackers can retrieve the message. So in that case, the confusion is the term who hides the relationship between the ciphertext and key. So this confusion and diffusion terms is very important. One is the relationship between the ciphertext and plaintext, and is the relationship between the ciphertext and key. If this confusion diffusion is increased, then obviously your scheme is very good. Third one called the round. Round to confusion and diffusion can be achieved using iterated product cipher, where each iteration is a combination of the S box, P box, and other components. Round means suppose first round. First round means there are one S box, one P box, and any other component we can use and generate a product cipher. So this is the first round. Again, we take the another S box, P box, and other components and generate another bit stream by taking the first round input as a first round data bit. Then it becomes a second round. So round is nothing but the iteration. Okay, these are the examples. See, first you take the 8-bit plaintext. From this 8-bit plaintext, you can supply the K1 key. Suppose there are a round key generator technique there. you can generate the key for your encryption scheme. The first K1 8-bit key has been used, and from this 8-bit key, you just take this uh, 8-bit and you take this K 8-bit and you can mix. So nothing but mixing you can perform the XOR operation here. So this key mixer will key has been mixed with the input bit. So suppose this is 10101100 and this key also again 11110000. So suppose these two 8-bit input and 8-bit key has been XOR. Then your data has been mixed with the key. Then you can take the S box, 2-bit S box, and for the substitution box another 2-bit has been generated. So in this way 4 S box and 8-bit has been generated. Then again we use the P box. P box is a permutation. This first bit will come to the second, 8 place, 7 place, 6 place, like this. So using this P box, a new bit stream has been generated. So this is not the input, this is not the plain text, this is the intermediate ciphertext. So this first, the combination of these three is considered as round one. And from round one, we can get intermediate bit pattern. Then you use the another 8-bit middle text. This 8-bit middle text is the same as this input stream. Then again we apply the round two. The same process with this, but the different key. So same process with different key. Again it has mixed, then substitute, again combination and get the new another bit pattern. So in this way, if we increase the round, then obviously this input bit pattern has been changed and their cipher and plain text relation has been decreased. So the diffusion has been increased, and again also key K1 K2, the relation between K1 K2 and the cipher text is again also decreased. That means the confusion has been increased. So in this way, we can use the product cipher and different rounds and different S-box, P-box and some techniques by which the data has been encrypted. And obviously on the sender end, receiver end, it can be easily decrypted. Now I can just explain what is in diffusion and confusion. Suppose we have taken the bit at the 8th place. Say from the 8th place, it may become, say maybe it is 0 or maybe 1. Now, how it can be mixed for the round C? Suppose you taken the first bit, a 8 plus bit, it may be 0 or maybe 1. Consider this is 0. Now 0 and the 8 bit of key, it has XOR with this 8 bit key. So then it become either 0 or 1. So this come to the two places, that is 7 and 8 place. Again, these two places shifted to 2 and 4 place. This was same bit will come to the 2 and 4 place. Again the K2, that is 2 and 4 place has been XOR, then goes to the substitute box, then it can generate 1, 2, 3, 4 places. This 1, 2, 3, 4 place come to the 1, 3, 6, 7. So this 1, 3, 6, 7 places bit, it may be 0 or 1, anyone. These all are depends on the bit of plain text 8 bit. If it is 0, then these 4 bits relations of this 4-bit data may be changed, or if it is 1, then again it may be changed. So obviously this 1 bit means plain text 1 bit and cipher text, it depends on 4 bit. So there is no relation. This relation hiding is called the confusion and diffusion for the plain text and cipher text. And for the confusion, see the 8-bit taken as 8-bit of the key in the first 8-bit, and there is a plain text 8-bit and XOR. Then we get the then what will be the result? Okay, it goes to the S4. Then again 7 and 8 place will change to the 4, and finally 1, 3, 6, 7 has been generated. This is the ciphertext. So these 1, 3, 6, 7 4 bits are there. That is depends on the 8 bit of the K1 and 2 and 4 bit of the K2. So can you say that is there any relation? We see 8 to 4, but it is 1, 3, 6, 7. So there is no relation. Again, it is only 8, but it is 1367. So there is one again. So this type of diffusion confusion can be arise when the ciphertext is uh, less relationship or there is more relationship with the plain text. It is called the diffusion, and the ciphertext is not related with the keys, then it is called confusion. So if our scheme, generated scheme, has more confusion diffusion, then obviously the hackers or adversary cannot retrieve our message. Okay. Now, two classes of product ciphers. One is called the crystal cipher and the non-crystal cipher. And for crystal and non-crystal, there are two types of product ciphers are here. For the crystal cipher, Crystal designed a very intelligent and interesting cipher that has been used for decades. A crystal cipher can have three types of components: self-invertible, invertible, and non-invertible. So in a cryptography, a crystal cipher is a symmetry structure used in a construction of the block cipher named after the German-born physicist and cryptographer Horst Crystal, who did pioneering research while working for IBM. What is this cipher? See, the crystal, the first crystal cipher. The plain text has been taken and then mixed. Mixer means the XOR. First XOR has been used. How? We will first take the k bit and it put into a function f of k. Then it XOR with the plain text. Then it becomes the ciphertext or encryption. And C1 has been generated. This is the first thought in the crystal cipher design. First thought of the crystal cipher design. And then this ciphertext become an XOR and get the plain text. So diffusion hides the relationship between the ciphertext and plain text. Okay. So in this way, this is another one called the improved um, crystals. The left and right bit has been divided into two parts. So suppose the bits are 8 bit, then we just divide it into 4 into 4. Then this left side will come to directly with the XOR with the function of a what is called the key and the right side data. So you take the right side data and key, put into one function, then the result will come. Yes, the result will go XOR with the left hand side, and the left hand side bit has been generated. And directly right hand side come to the right hand side. Okay, so this is an improvement of the crystal. So in this way, if you use the two round, then see first one is L1, second is R1. R1 will go to the function of R1 K1. Then some work will be generated, work will be done here. After that, some bit will come and XOR with the left hand side. Then there is a swapper. It will swap the data, means left hand side will go to the right hand side and right hand will go to the left hand side. Again, the same thing has been used. The right hand side will come to the RTK2 and get the result and mix with the L1. Again, swapping is there. So in this way, round 1, round 2, round 3, and round 16 you can use. Then we see that there is no relation between the input and output, input and cipher, means plain and cipher. Okay. And non-crystal ciphers use only the invertible component, the component in the. So sometimes non-crystal ciphers have been used, but this in the encryption cipher has the corresponding component in the decryption cipher. So it is sometimes this can be used. It is only invertible, means it can directly reversible. Okay, so okay, leave it this one. So today these are the part we have discussed, that is the modern symmetry cipher. If you have any question, কারো কোনো কোশ্চেন করা আছে?
স্যার এক্সামে কোশ্চেন্স কেমনি টাইপের আসবে, মানে এইগুলো টপিকগুলোর উপর?
এই ক্রিস্টাল সাইফার